Now let's move on to question number 5. Question number 5, we have cos inverse 4 by 5 plus cos inverse 12 by 13 is equals to cos inverse 33 by 65. And we have to prove that. Now we can solve this. We can prove this using the earlier formula which we have used in previous video. And now we will use alternate method to solve this, to prove this now. So first you have to write some important formulas so that you can directly solve this type of question. Okay. Now I am writing it here. You can note it down. Okay. Let me put into the red bracket. So first formula. If sine inverse of x plus sine inverse of y is given that, so we can directly solve into sine inverse x under root of 1 minus of y square plus y as under root of 1 minus of x square. We can directly solve this. If we have second important formula, which is sine inverse of x minus sine inverse of y, then it will be equal to sine inverse of x under root of 1 minus y square minus of y into 1 minus of x square. So this is the formula. Formula is almost same, but in the plus we have to write plus, and in the minus we have to write minus. Just change it. Okay. Now moving on to next important formula, which is third one, which is as if we have cos inverse of x plus cos inverse of y, it will be directly solved by this formula cos inverse x of y, x into y minus under root of 1 minus of x square into under root of 1 minus y square. This is minus sign and this is multiplication sign. Okay. Now the fourth and last one, cos inverse of x minus of cos inverse of y. Same as above, but there should be no minus sign. There will be plus sign. So cos inverse x into y plus under root 1 minus x square into 1 minus y square. So these are the 4 important formula. By using this, you can directly solve this type of a question and you'll save your time in examination. So we'll use this formula to solve this question. Now in question we have cos inverse x plus cos inverse y. So we'll use formula number 3. Okay. Let's write it down here. Let me change the color. Yeah. So we have cos inverse 4 by 5 plus cos inverse 12 by 13, and we have to prove it as cos inverse 33 by 65. So this is LHS side. This is RHS side. Take LHS side. So from this formula, check here above. Third formula we'll write cos inverse. In place of x, we'll write 4 by 5. And in place of y, we'll write into 12 by 30 minus under root 1 minus x square, which is 4 by 5 whole square into 1 minus y square, which is 1 minus 12 by 13 whole square. Now we have put the values. Now we'll solve one by one. Actually, here it is not 12, it is a 30. 12 by 30. Yeah, now it's good. So, cos inverse. 12 into 4, 48, or 13 into 5, 65. So, we can write it as a 48 by 65 minus 1 minus 4 square is 16 square divided by 25, which is 16 by 25 into 1 minus 12 square is 144 divided by 13 square is 169. Now into the next step, cos inverse 48 upon 65 minus, now we'll take LCM 25 minus 16. What we'll get, which is 9 by 25. And into 169 minus 144, take LCM, which is 169 minus of 144 divided by 169. So into the next step, cos inverse 48 by 65 minus. Take it out from the bracket, which is 3 by 5 into under root. So 169 minus 144, which is 25 by 169. Sorry, 169. Now moving on to the next. Cos inverse 48 by 65 minus 3 by 5 into, moving out from the square root, which is 5 by 169. So 5 will cut, which is equal to 3. Sorry, 169 as a, let me erase this, 1 5 by 3 by 5 into 5 by 30. Cut this to, we'll get cos inverse 48 by 65 minus 3 by 30. We are almost here. So let's put cos inverse 48 by 65, taking LCM. So we'll take LCM 13, 65, 65, which is 48 minus 13, 5, these are 50. So cos inverse 48 minus 15 is 33 by 65. Now here it is same as a RHS side. So hence LHS is equals to RHS. That exactly write this whole procedure in examination for your 12th board, you'll get marks. And don't forget to mention the formula in the right hand side. Okay? If you want to note it down, note it down.